Hello everyone. In the last video we have seen that how can we codify various color with the help of coin and dice. In this video we will see how we will write that codified things into binary digit. So how can we write different code generated? In the previous video, if you have not watched, I will be pasting a I link. You can go and watch that. So suppose if we are giving red color a code of H, H and T. In the last video we have seen that we can assign different color different code. So how can we give a binary coding for this? Means how can we assign binary digit to this? So you have already gone through this table if you are watching my previous lecture also. So we will be only looking at these two things currently because we are dealing with coin. So coin, head, tail and the binary digit. Got that? So we will be assigning every head 0 and every tail 1. So let's see for black and white. So in the previous video we have assigned black as head and white as tail. So what can we write? Head as 0 and tail as white. So every black color has now a binary digit of 0 and every white color has a binary digit of 1. So let's look at other four color. Suppose now means in the previous video we have seen that red color was assigned HH, orange was assigned HT, yellow was assigned TH and blue was assigned TT. So can we write in the binary form? We will write H as 0 and one another H as 0. And here HT, so 0 1, TH 1 0 and TT 1 1. So in this way we can assign this code binary digit. So now let's write the rainbow color using the binary digit. Means we have already written this thing in the form of coin state, means head and tail. Now we will be writing it into using the binary digit. So for red color binary digit will be 0 0 and 0, 3 head. Then for orange it will be 0 0 and 1. For yellow it will be 0 1 0. For blue it will be 1 0 0. For indigo it will be 1 0 1. For violet it will be 1 1 0. We have not used the condition TTH to assign any color, sorry, TTT to assign any color. If it was there, then we will give it as 1 1 1. So what we are doing above, miss, and why we want to represent them as number? What we are doing above, we are only codifying, only replacing T with 1 and H with 0. And why we are doing so? Because computer, miss, you might have heard that computer understand only 0 and 1. So we want every physical system to be stated as 0 and 1 so that it can be understood, oh sorry, understood by system, computer system. So numerical things make it easier to compute, means we can add, multiply or divide the numerical thing, so it makes computer to process the physical thing into the numerical format. Okay, now I want to check a general understanding of writing a decimal number. Suppose talking about this year 2022, what is your general assumptions of writing this decimal number? So this is the first digit place. Let's write it separately. 2 0 2 2. Okay. So this is at first decimal place, this is at second, this is at third, and this is at fourth decimal. What does you mean by decimal? Decimal means 10. So this is the first decimal place, means one's position. So it will be having 10 to the power 0. Now in the case of second decimal place, 10 to the power 1, then 10 to the power 2, then 10 to the power 3. Okay, so which then we are going to add this thing. So what we get from here? 2000, am I correct? Then this is 0, then it is 20, then this is 2 into 10 to the power 0. 10 to the power 0 is 1, so 2 into 1 is 2. When you add this, you get 2022. So what is going here? Every digit, this digit, this digit, this digit, this digit is representing these powers without, means they are playing a significant role. Here it is 0, so complete element become 0. So now see which one is playing the most contribution in 2022, in making 2022. This digit, this is only contributing 2. This digit, this is only contributing 20. This digit, this is contributing 0. And from here you can see that this digit is playing significant role. It is contributing 2000. So from here we can say that this is the most significant digit. This is the most significant digit. Can we write same for 3000? So here 3 0 0 0. So 3 into means from starting from here, 3 into 10 to the power 0, 3 in means 0 into 10 to the power 0, 0 into 10 to the power 1, 0 into 10 to the power 2, 3 into 10 to the power 3. And when we add these all elements, what we get? 3000. So which is the most significant bit here? 3. So what does each digit represent? Each digit are representing the power of 10. So every digit is representing the power of 10. because we are writing the decimal number. Decimal number means 10. 0 to means 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. From here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digits are there, so 10 decimal numbers. Now next question arises. We were continuously talking about the binary number. So in the decimal number there are 10 digits, means 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But in the case of binary there are two digits. So if there were 10 numbers, so we were giving it 10 to the power. Can we give same for the binary number? Let's see. So suppose we split this 1, 1, 0, 1, 1 and 0. Okay, we have split it. Let me spread it slightly more for convenience. 1, 1, 0, 1, 1 and 0. So this is at one's place. So again we will now in the case we in the decimal case we were writing 10. Now we will write 2. 2 to the power 0 into 2 to the power 1 into 2 to the power 2 into 2 to the power 3 into 2 to the power 4 into 2 to the power 5. So when we add all this, what we will get? So we will get starting from here 2 to the power 0, 1, 1 into 0, it is 0. 2 to the power 1, 2, 2 into 1, 2 plus 2 to the power 2 is equal to 4, and this is 0, and this is 2 to the power 4, 16 plus 32. If we add all this, what we are going to get? Can you calculate it faster and comment down? So we are getting 54 as the answer for the first question. So this binary number is representing 54 as a decimal. 54 decimal. This is means you might have one thing before going further. Let me tell you, you might have seen that in some places it is written, let me write here. In some places it is written 110 and this 2. This 2 represent the binary number. Suppose in some places it is written 54. If nothing is written, then we can assume that it is 10 decimal. But sometimes for some convenience, people write 10, or sometimes they write D, these types of D for decimals. Okay, so this is representing the decimal number. Okay, so let's go further, and can you write the decimal number from this binary number? You can pause and try it by yourself, and then we can check it further. So if you have done, so let's try 1, let me write this plus before 1 0, then we will go for 1, then we will go for 0, then we will go for 1, then we will go for 0. Here we are giving 2 to the power 0, here we are giving 2 to the power 1, here we are giving 2 to the power 2, here we are giving 2 to the power 3, 2 to the power 4, to the power 5. So this is 0, this is again 2, this is 0, this is 2 to the power 2 into 2, 8 plus 0 plus 32. Can you sum this all? So it is equal to 42. You can write like this also, or this also, or you can simply write it as 52. Now moving further, how can we write a hexadecimal number in the form of decimal number? Let me see. How can we write hexadecimal number in decimal form? So hexadecimal consists of 16. Okay, 16. In the decimal, we have already seen the digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Since we will be having 16 digit, how we are going to represent? Means 16 symbols should be there. These all are symbol 0, 1, 2, 3, 4. So there should be having 16 symbols. So what we do here, we starting, suppose for 10 we write A, for 11 we write B, for 12 we write C, for 13 we write D, for 14 we write A, B, C, D, then E, then for 15 we write F. Okay, so now we have all 16 symbol 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. So now we are going to represent 16 16 means hexadecimal number with this 16 symbol. So let's see, if you have not came across the hexadecimal number previously, let me show you something like how hexadecimal look. So suppose this is a hexadecimal number, so how it will be looking? So as previously done, it will be in the power of 16. You already know. So we will separate it. F 2 and then A. Okay, got that? Then since it is at first position, so 16 to the power 0, it is at second position 16 to the power 1, then here we will go for 16 to the power 2. You can use calculator here, no worry. Then we are going to add this. We have already gone from the above what this all thing represent. This is representing 10, 11, 12, 13, 14, and 15. So moving further, we will replace all this. For f, we will write 15 into 16 to the power 2 plus 2 is 2 into 16 to the power 1 plus for a we will write 10. 10 into 16 to the power 0. If you calculate it further, you will get the answer as, so it is equivalence to 3, 8, 8 and 8 decimal. Sometimes this is also represented as H or H for hexadecimal or 16. Okay. We were talking about the conversion from uh, we were first talking about decimal to decimal, means no need to convert, only we were understanding how we write. Then we converted binary to decimal. Then we converted hexadecimal to decimal. Can we go and convert decimal to binary? So now we are going to convert decimal number to binary number. So starting with some random number, let's take any number. For example, 21. Okay, we will take a small number. So what we will do? We will write 21 like this and factorize it. So 2 ones are 2 and 0. We get one reminder, so that reminder will be written this side. So we will again do 2 5s are 10, no reminder, so we will write 0 here. Then we are going to factorize 5 also. 2 2s are 4 and then one reminder, we will write this side, and then again 2 ones are 2, no reminder, so we will be writing 0 this side. So going uh, further, we will write it in the reverse order. This is a method. Okay, so what will be the answer? 21 decimal, which is represented in the binary format, which is 10101. Okay, so can we go further and verify whether our answer is correct or not? So 1, I will be writing directly. 1 into 2 raised to the power 0, 1, 2, 3 and 4 plus 0 plus 1 into 2 raised to the power 0, 1 and 2 plus 0 plus 1 into 2 raised to the power 0. When we add this all, what we get? We get our answer as 21. Okay. So we have verified that our answer is correct. Now we are going to understand about the ASCII code. This code. So what is the full form of ASCII? So it is American Standard Code for Information Interchange. So what happened? We have lots of symbol in this world, and there should be a certain code assigned to particular symbol so that there should be no confusion among the users across the world. So there is a standard set of code assigned to every symbol. So I will be listing this symbol. You can see the image here. No need to by heart this symbol. It is not necessary. You can always look it in the internet. So from here you can say that greater than sign has a binary code of 0 1 1 1 and 0 means again 1 1 and then 0 0. So there is no need to by heart this thing. You will easily get about this from internet. So looking at this, can we try to encode our name? You can try with your name. I will try with my name. So let's try to encode this thing. Here, mind that I am writing capital N and every number has a different ASCII code. So we will be looking at capital N, which has a binary number. Means binary, what has capital N binary number? 1 0 1 1 and 0. What about small e? It is 1 1 0 1 0 1. So there are two e, so I will be write 1 1 0 1 0 1, and for L it is 1 1 0 1 1 0. So you can write your name also in the binary format. You can always go for this, and people will able to decode it with the help of the this table. So one task for you, can you write your name in the binary form with the help of the table given here? You can also search the table in Google and you will find it in first place. So for the next video, we have understand a lot, and I think video is going too lengthy. So in the next video, for the next video, we will be studying about logic gates. I will try to finish the logic gate in the classical system. Then from the next chapters, I will go with the quantum gates. But first, before going to the quantum gate, let me finish the classical gate. Means simple aspects of what each gate and how it functions. So, thanks for watching this boring lecture. I will see you in the next video. Goodbye.